Assalamualaikum. Effect of heating time on the production of biochar-derived carbon quantum dots by microwave irradiation. Size-selective photoluminescence properties possessed by quantum dots due to quantum confinement effect and have a great potential of applications in modern biotechnology field, including bioimaging, biosensor, and biomarkers, as well as in medicine field. However, with such powerful performance are challenged by small but significant issues: toxicity. Potential environment hazards and strict synthesis conditions have limited their further development. This lead to the production of carbon quantum dots, or also known as carbon dots, to replace semiconductor quantum dots due to their low toxicity, biocompatibility, low cost, and chemical inertness, in addition to having similar fluorescence properties. There are three categories of carbon-based nanomaterial based on their dimensions of high aspect ratio: zero-dimensional, one-dimensional, and two-dimensional. Zero-dimensional carbon-based nanomaterial composed of carbon dots and fluorinets, where it is mainly in sphere. Semiconductor quantum dots has been used for quite some time in many fields. Unfortunately, their presence dominating are limited by their containing heavy metals element, which has potential health and environmental hazards. As a solution, carbon quantum dots has been seen as a potential. However, this research have certain limitation, which is the sample size is still in a small portion. Thus, it is difficult to find significant relationship from data. Limited amount of biochar source is the main reason. Next, we move to the second part, literature review. There are three main components under this chapter, which is on properties, synthesis methods, and applications. And there are three main properties that possessed by quantum dots, which is chemical properties, optical properties, and biological properties. There are two routes to produce carbon quantum dots, as stated earlier. The top-down method is breaking down large bulk material into submaterials, while bottom-up method is combining a smaller pieces into a complex system. Examples of top-down method are laser ablations, electrochemical oxidations, chemical oxidations, and many more. While for bottom-up methods are microwave synthesis, hydrothermal treatment, and thermal decompositions, and so on. In the applications, the center of the area of renewable energy are the advanced materials for electrocatalytic and photoelectrochemical hydrogen evolution reactions with UV-Vis and visible light from 1 to 450 nanometer, 125 carbon quantum dots P25 exhibited improved photocatalytic H2O evolutions under irradiation because of this carbon quantum dots acting as an electron reservoir to improve the efficient separations of the photosynthesizer to sensitize P25. The important issue for the existence and development of mankind in which will attract extensive attentions is the environmental pollution in air and ecosystem. Photocatalytic method is one of the methods to solve the problem of pollutions. A vast majority of organic pollutions into CO2 and H2O completely degrade by photocatalytic oxidation technology. Successful attempt has been made in the dechlorizations and detoxifications of organic dye effluents by using photocatalytic oxidations. Drug delivery and detection system, an effective route to develop cell screening and disease diagnosis. Positive surface are the surface potential of PEI modified carbon quantum dots absorb the negative DNA for gene transfer. Next, Chapter 3, Research Methodology. There are also three main parts on this chapter, which is materials. Next is synthesis. There are five main synthesis procedures. First one is solvent preparations, followed by microwave treatment. Next is centrifugations, filtration and drying, and lastly, collecting data from characterization. There is only one parameter under study, which is time, where we have five variables starting from 1, 3, 5, 7, and 9 minutes. The properties that were studied is the optical properties, chemical bonding, and morphological properties. CQD were synthesized from EFB via microwave irradiation method. CQDs were obtained in liquid phase after carrying out the step as mentioned before. The conversion of carbon quantum dots increasing from 1, 3, 5, 7 minutes and decreasing from 7 to 9 minutes. The optical properties of the obtained carbon quantum dots were studied through photoluminescence, UV lamp photoluminescence spectroscopy (PL), and UV visible spectroscopy. Photoluminescence is the emission of light from any form of matter after excitations from another light source. The photoluminescence properties of the sample was first seen under an ultraviolet lamp. The discharge energy has wavelength in the visible light region which can be seen. As for UV-Vis spectroscopy, through graph here, UV-Vis absorptions of carbon quantum dots As for PL spectroscopy, as can be seen from the figures, all the 5 samples showed an almost Fourier transform infrared spectroscopy (FTIR) were used as
Fourier
fractional
transform
characterizations
infrared
by
spectroscopy
identifying the
FTIR
presence
were
of a
used
certain
as
structure. For the investigation of morphology and average particle size of carbon dots, high-resolution Next, we come to last part, which is on conclusion and recommendation. The aim of this study was to synthesize EFP-based carbon quantum dots by varying heating time using microwave method. The constant variable in this study were power setting at low level, which is around 300 watts. To carry out this microwave procedure, the obtained carbon quantum dots were then characterized and analyzed and were studied based on its optical and structural characteristics. The optical image taken under UV lamp radiates a blue PL for all the carbon quantum dot sample obtained, and carbon quantum dots produced at 7 minutes microwave heating time shows the brightest fluorescence. PL peak intensity of microwave heating time at 7. The recommendations for this project is we can vary the microwave power setting and temperature